Dear students, in this session, I am going to cover the summary of the module 1. In the previous session, we discussed about the rectifiers and its types. We have two different types of the rectifiers. One is uncontrolled rectifier, where diodes are used, and next one is the control rectifier, where thyristors are used in place of the diodes. In the control rectification, the control block is required to control the firing angle of the thyristors. See, the summary of the module 1 is nothing but, so what all the topics we covered in this module and what all things you studied so in this module. So let's start with the power electronics connectivity, wherein all this power electronics is connected. So power electronics is connected by the circuit theory. Power electronics is connected by systems and the control theory. It can also be connected with the signal processing, simulation and computing. And electronics used to control and to convert the one form of the power into another form of power. Solid state physics, because the power electronics which depends upon the switching of the semiconductor devices. And electromagnetics also involves this power electronics, and power electronics is also connected by the power systems and also electric machines. So this is the overall connectivity of this power electronics. So let us see. So what is the definition of the power electronics? So we covered the definition of the power electronics in different ways. One such way is that power electronics, which is the combination of the electronics and power and the control unit. The control which tells about the continuous, discrete and dynamic characteristics, and the power which this is static and rotating power equipment, and electronics which deals with the power semiconductor devices and its switching. Next thing is that so history of the power electronics. So this is evolved in the year 1900 with the invention of the mercury arc rectifier, nothing but vacuum tube rectifier thyratron, and the first thyristor which is invented in the year 1957, and in the mid 1970s power diode thyristors is evolved. Same, that is application of the fast switching fully controlled semiconductor devices, and late 1980s the various power semiconductor devices are evolved, like GTO, gate turn off thyristor, then gate turn off resistor, and then power MOSFET thyristors, that is microprocessor, and later IGBT power MOSFET thyristors are evolved. So we divided this the phases into the four phases. We divide the evolution into four phases. One is the free history, second second one is the first phase, followed by second phase and the third phase of the invention. Next is power electronic converters. We covered the four different types of power converters. Say, by observing the figure, the sinusoidal signal indicates that it is an AC signal, and the equal mark symbol which indicates the battery symbol or the DC symbol. See, the first one is conversion of the power from AC to DC. So if the AC is converted DC, means it is called as an AC to DC converter, which is also called as a rectifier, means control rectifiers. So next is DC to DC. So what is that? The fixed DC into the variable DC. Fixed DC into variable DC is called as an DC to DC converter, and it is also called as a chopper. Next is DC is converted to AC. The fixed DC is converted to alternating AC. So this is called as an what is a DC to AC converter, nothing but the inverters. And finally, AC to AC you are observing, this type of converter is called AC voltage controller. So we have two types of AC to AC converters. One is AC voltage controller, where the output frequency is same as that of input frequency, and the cycloconverters where the output frequency is not same as that of the input frequency. So these, like this, we have the 4 different types of the converters. One is AC to DC, is also called rectifier. Next is DC to DC, nothing but choppers. Next DC to AC, nothing but inverters. Next AC to AC, nothing but AC voltage controllers, and AC cycloconverters. So this is structure of the power electronic system. So what are the elements which are necessary for the power electronic system? So power converter, controller, this is the, and this power converter and the controller is the fundamental blocks of this power electronic system. The power converter which converts the power from one form to the another form, which is suitable to run the loads. And next thing is that, what are the devices available for the circuit design? You are observing resistors, capacitors, you are observing magnetics, means the transformer, you are observing transformer secondary and primary, and linear mode you are observing, switched mode you are observing. So these are the devices which are required, which are available for the design of the power electronic circuits. Applications. So we discussed various applications of the power electronics. One such application, industrial application, you are observing, it can be used in motor drives, it can be used in electrolysis, electroplating, induction heating, it can be used in welding, arc furnaces, ovens, it can also be used lighting. So these are the industrial applications of the power electronic system or the power electronics. And later is the photovoltaics. We can also use power electronic system in the DC bus, in the AC bus we are using, and diesel generator. So all these things we are using this means it can also be photovoltaics. Photovoltaics is composed of all these the devices like a PV array, a DC bus, AC bus, diesel generator, etc. Our next application is a transportation. So we can use this power electronic devices in the trains and locomotives, in subways, trolley buses, magnetic levitation, in electric vehicles. In the electric car technology, we are using this power electronic system where inverter is playing the vital role. Battery and the inverter are the basic building blocks of this electric car, electric cars. Automated electronics, ship power system, it can also use the aircraft power system. These are the applications of transportation department. Trends in power electronics. What are the trends in power electronics? It is estimated that in developed countries, now 60% of the electric energy goes through some kind of the power electronic converters. 60%, imagine 60% of the electrical energy which goes from the power converters, maybe from DC to AC or AC to DC before it is finally used. Power electronics has been making major contribution to better performance of the power supplies and better control of the electric equipment. It can be used in the energy savings. It can be used in environmental protection. These are the trends in the power electronics. So thank you for watching this video.